Hi everyone, today I'm going to be going over question 53 from the chapter 6 bingo problems. So this question was really interesting and I'll just read it because it's kind of an interesting concept. It says, on December 27th, 2004, astronomers observed the greatest flash of light ever recorded from outside the solar system. It came from the highly magnetic neutron star SGR 1806-20. And in parentheses it says a magnetar. And then during 0.2 seconds, this star released as much energy as our sun does in 250,000 years. So that's a crazy amount of energy that's being dumped all at once. But anyway, so then the question then wants to know if it says what was the average power output in term of the magnetar in terms of our sun. So to do this, we know that the time was 0.2 seconds. It was the amount of years or time that it takes the Earth to produce that much energy is 250,000 years. And then we also know that the energy of the sun equals the energy of the magnetar. And so we use our power equation since it wants to know the power, which is P equals the energy over the time. And so this question has a lot of unit conversion and things like that. So first of all, time is in seconds and time is in years. So we're going to need to change the years to seconds. And so we do that by, so we'll just say 2.5. Alright. Yeah. So to get this into seconds, we know that 1 year equals 365 days. 1 day, 24 hours. 1 hour, 60 minutes, 1 minute is 60 seconds. So throw that in the calculator and we end up with the time being, let's see, 7.884 times 10 to the 12th seconds. That's a lot of seconds in 250,000 years. So I'll erase this since we don't need this anymore. Okay, so we know that time in seconds. We also know, so let me write this up here actually. So we know that now. So now what we need to do is manipulate our power equation to solve for energy. So we know that the energy equals power times time. And now, since we know that these two are equal, we can then say that the power of the sun times the T sun equals the power of the magnetar, which I'm just going to say mag because I don't want to write out magnetar every time, even though it's a really cool name, times the time of the magnetar. And then now what we want to do, it wants to know the power of the magnetar in terms of the power of the sun. So we'll solve for power of the magnetar, so we'll just divide that out. So that equals P magnetar All right, so now we've got it all down in our variables. Now all we need to do is plug everything in. So the power of this sun, we'll just leave because we're not actually given a value, so it wants it in terms of that. But the time of the sun we know is this, which, if you remember, was 250,000 years that it took the sun to release the same amount of energy. So we know that P mag equals P sun times 4.88. Oops, 7, not 4. 7.884 times 10 to the 12th seconds over T mag, which we know is 0.2 seconds. Our seconds cancel, and so what we're left with is, when we divide this out, then we know that the P mag equals 3.94 times 10 to the 13th. I'll write that a little nicer. P sun. So that's crazy. So it means that the power of that magnetar is 3.94 times 10 to the 13th power times the power of the sun. So I had a lot of fun solving this problem. I thought it was really interesting. I'd never heard of magnetars before. So hopefully you enjoyed watching this. Hopefully you learned something, and I'll see you in the next video. Thanks.